Hey, it's your boy Reese, and we're going to be talking about buoyancy. So, buoyancy arrives from water or fluids. The deeper down you go, the more pressure there is. And pressure is force over an area. So, if I press my fingers into my hand, there's a force being exerted over the area of my finger. But when I exert it like this, it's the same force over a greater area, which means less pressure. And so, deeper down you go, if you place an object down, it's going to have the bottom half and the top half. Since the deeper down you go, there's more force or more pressure exerted over the same area. It's going to have a greater force exerting upward than downward, which causes it to rise. This can be calculated with Archimedes' principle, which is a very handy way to calculate this. So you have the density of your fluid, which for water happens to be 1. The volume of the displaced fluid, which is the exact same as what you put inside. And then gravity, which is always the same on Earth. So now we're going to calculate this and show in a cool little experiment. Whoa!
Oh, we're on this part of the video already. Okay, well why don't we go ahead and see buoyancy in action. Here we have 2 different bottles, but with different liquids inside, with different densities. Let's see how that plays out with buoyancy. Now you see here the Coke bottle floats, yet the water bottle sinks. Let's see that in slow-mo. Now let's compare 2 objects that float. Here we have the Coke bottle, but now we've emptied the water bottle and it's just filled with air.
So, to recap, the buoyant force is dictated by 3 things. First off, the density of the fluid in which the object is, the gravitational force field strength, and the volume of the object. This, in conjunction with the gravitational force, which is dictated by the mass of the object and the gravitational force field strength, dictates the net force of the object in the vertical direction. And then, when we take that all into account and divide by the mass, we can get the acceleration either up or down, i.e., floating or sinking, of the object that you just saw in the videos. For example, the bottle filled with air had a lower density than the water and had a very low mass, so the acceleration went upwards and against the gravitational force to allow the bottle to float. Now we can see applications of this very obviously in boats, which have, since they're floating, the exact same of mass above water as they do below water. Certain vessels, like submarines, utilize this fact and the mass inside of the boat to allow the vessel to go up and down within the water due to air chambers within the submarine and how those are filled with water or filled with air to dictate how far up the submarine is. We also see this in plastics and how those float in the oceans. This can lead to pollution of the oceans, but companies can also take advantage of this by utilizing the object's flotation to collect them and help to clean up the oceans.
Whatever happened to predictability? The milkman, the paper boy, evening TV. Did I get delivered here? Somebody tell me.